Hi, this is your host Chantel, and I welcome you to 5 and 5 Live, where we interview experts on various advanced technology programs, inventions, and developments. Our format is 5 questions, 5 answers in 5 minutes. At the end of the interview, we provide additional information. So let's get started, and thank you for watching 5 and 5 Live.
Hi, Kaydon Stanzione here with Jay Carter, an amazing inventor and father of some very unique inventions that include wind turbines, steam-powered cars, and the world's first successful single-rotor aircraft that has been able to achieve a mu greater than 1. We welcome Jay here to 5 and 5 Live, and we look forward to hearing more about his inventions. So let's get started. Jay, what inspired you to tackle the enormous task of achieving a helicopter mu greater than 1?
After selling my wind turbine company, I was looking for something to do. I've been a pilot since Texas Tech, when I also built 2 autogyros, the last one being nearly all composites. The idea of building a 5-place gyro appealed to me, but I first had to convince my wife. She liked to fly, and she knew I needed a fun project to keep me engaged. At this point, I did not know anything about mu1 or its advantages. However, I intuitively knew if I added wings, it would improve the gyro's performance. What I did not realize was that by adding wings, as the aircraft flew faster and produced more lift, the pilot would instinctively push the control stick forward, which reduced the airflow through the rotor and slow it down. As I started calculating the aircraft drag, I realized the rotor drag was a function of RPM cubed. 1/3 reduction in RPM reduced the drag by a factor of 27. Since the rotor could provide VTOL capabilities and incremental lift over 200 miles an hour, the wing in its drag could be sized much smaller. This dramatically reduced rotor and wing drag made me question, why has it not been done before?
Jay, it's amazing what you have accomplished. What was your initial development plan to achieve building an aircraft with a mu greater than 1?
I had to prove to myself that the rotor could be slowed down and still be stable. I initially identified and felt I had resolved 5 key issues required before we could make this happen. Therefore, I could not explain why this had not been done before. So I called Ken Warnicke, who at the time was program manager of the Bell XV-15 tilt rotor. He told me it was a waste of my time, that Bell had looked at it previously as well as other companies and determined it was impossible or impractical. I again went over my analysis and could not see anything wrong, so I asked Ken and asked him if he would just review my analysis and show me where I was wrong, so I could get on with my life. He jokingly bet his retirement pay that he could find the mistake. After 2.5 hours, he still could not find any mistakes, but asked me to leave it with him as he was sure he could find the error. Well, that was enough for me, and so we built a 1/6 scale model of the rotor and tested it in our poor boy wind tunnel. The rotor was mounted on the front of a pickup, and we eventually went down the highway at 80 miles an hour, with the rotor slowed to a tip speed of 10 miles per hour. This resulted in an advance ratio of 8. The rotor was so stable that the turbulence from passing semi-trucks did not cause the flapping to exceed 12 degrees. When I showed Ken the results, he and 3 other Bell employees, who had all retired at the same time, came on board and became my first investors.
Obviously, building a unique aircraft requires unique facilities. What facilities did you need to build so that you could successfully build your SRC aircraft?
I had a partner who provided a 30-foot by 60-foot building and a machine shop that built all our metal parts. We built a 140-foot diameter by 16-foot deep pit to safely test rotors, propellers, and static test our first quadricopter. We built a drop test fixture to test our 24-foot per second landing gear. And recently we built a Lazy Susan aircraft test stand to check all aspects of the new hybrid quadricopter, including full throttle, limited jump takeoffs, and yaw control.
Entrepreneurs generally face a lot of challenges, regardless of what the invention is. What are some of the challenges you faced in building the aircraft?
How to make the retreating blade produce the same lift as the advancing blade when the retreating blade was seeing complete reverse flow. I analytically believed it could be very stable up to 500 miles an hour without the advancing blade tip exceeding Mach 0.95. How to stably slow the rotor and aerodynamically control the rotor RPM without hunting. Developing a pilotless automatic mechanical rotor collective that works from jump takeoff to cruise and back to zero roll landings. Developing an all-mechanical landing gear that could determine an impact velocity up to 24 foot per second in the first inch of travel, and then apply the required pressure to make a constant deacceleration of less than 6 Gs over the entire stroke. Developing an automatic yaw control that was very accurate and fast acting regardless of the wind.
It's so exciting, Jay, on what you have done with this aircraft that nobody else has done. However, the SRC is not your only invention. It's your latest invention. Please tell us some of the other inventions you've had before taking on the challenge of building the SRC.
While I was in college, I built 2 auto gyros, the last one mostly composite. In 1970, another fellow my age and I started working on a steam-powered Volkswagen Squareback. In 1974, when I was 28, we took the car to Ann Arbor, Michigan, where it became the first car to meet the 1977 emission levels proposed by Congress. The car and its achievements made the front cover of most major newspapers and the front cover of Popular Science in 1974. About 4 months after I testified, Congress passed the 1977 emission requirements. In 1976, I started working on a unique 2-bladed teetering downwind turbine mounted on a tilt-up tower for ease of installation and maintenance. We used 4 guy cables, a gin pole, pulley block system, and a truck or backhoe to pull on the cable, and it could be raised or lowered in about 5 minutes. No cranes were required. Ended up manufacturing, then shipped and installed our wind turbines in India, France, England, Scotland, 300 miles north of the Arctic Circle, throughout the western United States, including 2 Hawaiian islands. I sold the business in 1992, and in 1994 I started developing the slowed rotor compound cartocopter.
Thank you, Jay, for being with us. We really appreciate your time, and we look forward to future inventions and things you may have up your sleeve for tomorrow. Good day.
Thank you for watching 5 and 5 Live. We hope you found the interview to be informative and that it has met your expectations. Please visit our website for any additional information the expert has made available for download. Also, while at our website, if you have an exciting product, research, or business that you would like to share with our audience, please let us know. We would love to hear from you. Thank you and goodbye.